Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x divided by 3 times x divided by 3 is equals to 3 divided by x times 3 divided by x. So here we multiply numerator with denominator and denominator with denominator. So we have x times x becomes x square divided by 3 times 3 becomes here 3 square, and this is equals to again 3 times 3 becomes 3 square, and x times x becomes here x square. And now further in the next step we need more simplifications here, and now we cross multiply the terms and we multiply this 3 square with this 3 square and this x square with this x square. So here when we cross multiply the terms, we get x square multiplied by x square equals to 3 square multiplied by 3 square. And now further in the next step, so here you see that x square multiplied by x square becomes here x to the power of 4 is equals to 3 square multiplied by 3 square becomes 3 to the power of 4. So after this little bit simplification, we get our given equation into the fourth order equation. It means that this equation has 4 or less or equals to 4 roots. We need to find all that roots of this equation. So we move the term from right hand side to the left hand side, and we get x to the power of 4 minus 3 to the power of 4, and this whole equation is equals to 0. So we rewrite this equation as this is x to the power of 4, we write it as x square and its whole square, minus this is 3 to the power of 4, we write it as 3 square and its whole square. And now in the next step we use here the nice algebraic formula. You know about that. If we have a square minus b square equals to a minus b times of a plus b. So according to this rule, you see that the base of this term is our a and the base of this term is our b. So we use here the below formula to the above equation. This will be written as in this form. We have the first factor is a minus b. The value of a is x square minus the value of b is 3 square. Again, the value of a is x square, the value of b is 3 square, and this whole equation is equals to 0. So we again apply the above formula into the first factor, and this will be written as x minus 3 times of x plus 3 into this is x square plus 3 square, and this whole equation is equals to 0. So now we divide this equation into the three cases, and here we have the first case is we write x minus 3 is equals to 0. The second case is we write x plus 3 is equals to 0. The third case is we write x square plus 3 square is equals to 0. So from first case we easily get the value of x is equals to 3. The second case we get the value of x is equals to minus 3. From this case we move the term plus 3 square to the right hand side, and we get minus 3 square. So here we get these are the two real roots, that is x is equals to plus minus 3, and now here we need to solve this equation in order to get the other roots. So for removing the square sign, we apply here the square root on both of the sides, and this will be written as minus 3 square and its square root. These 2 and square root are gone, and we get here x is equals to, we know that when negative sign appears inside the square root sign we get iota, and these 2 and square root are gone, and we get here 3 only. Further we apply square root on both of the sides, so that's why we write here plus minus sign. So we have these are the other two complex roots of the given equation. And now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this, we need to copy down a given question statement here. It is x divided by 3 multiplied by x divided by 3 is equals to 3 divided by x times 3 divided by x. So here in this side we verify first x is equals to plus minus 3 in this side, and here we verify x is equals to plus minus 3 iota. Now we substitute x is equals to plus minus 3 on both of the sides, and we check its behavior, and this will becomes plus minus 3 divided by 3 times plus minus 3 divided by 3 is equals to 3 divided by plus minus 3 into 3 divided by plus minus 3. In the same pattern, we substitute these values here and we get plus minus 3 iota divided by 3 times plus minus 3 iota divided by 3 is equals to 3 divided by plus minus 3 iota into 3 divided by plus minus 3 iota. So we substitute all the values on both of the sides, and now we check its behavior after simplification of the terms. And here you see that these 3 and these 3 are gone, these 3 and these 3 are gone, and we get here plus minus 1 into plus minus 1 becomes plus minus 1 square. In the same pattern, these 3 and these 3 gone, these 3 and these 3 are gone, and we get here 1 divided by plus minus 1 whole square in the denominator side. So we know that when the base is negative and its exponent is an even number, so this will gives us the positive answer. So the left hand side gives us the positive one. In the same pattern, the right hand side is also gives us the positive answer. So we get here 1 only. And now here you see that these 3 and 3 are gone, this and this are gone, and we get here plus minus iota square. In the right hand side, this and this and this are gone, and we get here 1 divided by plus minus iota square. So we know that the plus minus square becomes positive and iota square is equals to negative 1 in the same pattern, and this value is also equals to negative 1, and we clearly get here minus 1 equals to minus 1. So both of the values are satisfied our given question statement. So finally we have the solution set of the given question is plus minus 3 into plus minus 3 iota. This is the final answer, and thank you so much for watching this video.